going to review our partial quotient theory that we've been doing for a couple of weeks just to make sure that we're all ready to move on to the next process in our division lesson. So division, Devin, we've been working on partial quotient. What does that mean, partial quotient?
It's like half the answer.
Half of the answer, okay. Parts of the answer come about through our process of multiplying to get to the quotient. So let's take a look at a simple partial quotient problem that we've done. Something like 6 dividing into 482. So the first thing with partial quotient is we extend our line down kind of like hangman, right? And then I'm going to divide what I know about 6 into 482. So I come over here and I think about what times 6 do I know? What's friendly about 6?
40.
Wow, 6 times 40. Okay, using some mental math, what is 6 times 40?
240.
240. Very good. And 240 is less than 482, so I can subtract from that. So 2 minus 0 is 2. 8 minus 4 is 4. 4 minus 2 is 2. Very good. Now what can I do? Can I do that one again, Anne?
Yeah.
Yes. So I can do 6 times 40 that Ella gave us again. So you get 240. One more time, subtract. 2 minus 0 is 2. 0, 0. So I'm left with 2. Can I do anything else with that? No. So what do we call 2, Casey? A remainder. So we're going to come over here and add our, what are these numbers called again? It's the name of the process.
Multiplication.
Not multiplication. What is this called?
Oh, partial quotient.
Partial quotient. Good. So I'm going to add my partial quotients. 40 plus 40 is how much? 80. So my 80 is my quotient with a remainder of 2. Everybody remember that?
Yeah.
Perfect. So now what I want to do is I'm going to flip to a new slide. We're going to do the same problem, but I'm going to show you the standard algorithm of division. There's a little way that can help you. Let me get that 6 and 482 again. There's a way to help you remember the steps in the standard algorithm. Is kind of funny. How many of you have ever eaten at McDonald's? Right? They're good, huh? At times.
Yeah.
Not as good for you, but good. So there's a little analogy that helps you remember, not an analogy, but like a little poem thing that helps you remember the steps in division. You already know it, Dylan? What is it?
Does McDonald's sell cheeseburgers?
Right. Does McDonald's sell cheeseburgers? Well, we all know McDonald's sells cheeseburgers, but this helps us remember the steps for standard algorithm division. The D, what do you think the D might stand for in math terms, Abigail? Divide. What do you think the M might stand for, Emma?
Multiplication.
What do you think the S is, Kirsten?
Subtraction.
Ooh, a C? Angelina?
Check.
Check. Very good. Check your work. And a B. You know it, Ann?
Bring it down.
Ooh, gosh, you guys already know some of these. Did your parents teach you?
Yes.
Yeah, so
No.
they kind of gave away some of the answers early, huh? All right, so these steps help you remember the process when you're doing division. We start with divide. So you come over here to the 6. And just like we did before, you thought about friendly numbers. But with this kind of division, we have to go back to the basic facts of multiplication. So you want to look at 6 and think about, okay, what are some multiplication problems, some multiples of 6? Then we look inside our division house here. The very first number we encounter is a 4. Now, not thinking about place value, I know that's worth 400, but not thinking about place value, can 6 go into 4 if I was dividing? 6 If I have 4 erasers, can I share those with 6 people?
No.
No. So 4 is not divisible by 6. It's too small. So now I'm going to look at 48. I'm going to join the 4 and the 8 and think of this now as 48. Even though I know it's technically 480, right? But with standard algorithm, we kind of leave place value to the side for a moment. Can 6 divide into 48? Definitely, because 6 is much smaller than 48. Now, with standard algorithm, it does not have to go in evenly, although I think we got a little lucky with this one. But it doesn't have to go in evenly, it just has to get close to it. So what times 6, who knows there's 6's, what times 6 will get me close to or on 48, but we can't go over? Evan?
8.
8. Look where I'm going to put the 8. I'm going to put that 8 right above the 8 because I divided into 48. So the last digit is an 8. 8 times 6 is what? Alla.
48.
Yeah, we got lucky there. 8 times 6 is 48. Guess what I do next? I just multiplied, now I subtract. Notice how everything happens right here. And notice how everything stays in a nice straight line. You see that? I haven't bothered with the 2, have I? I'm ignoring the 2 temporarily. So what is 48 minus 48? And 0. Okay, so I subtract and get 0. What's my next step? Check. What do you think it means to check? Angelina.
Like, check your work and like how you've done. To
Okay,
make
you
sure
might.
everything's right.
Sure, you might check your work to see if you've done it right. What else might you do? Devin.
You might check and see if it's like how we did it the other way. You might check and see if that's close to what we had for the answer the other way. So we would check and see if that was in the exact same place as the other way we did it.
Okay, we could, but consider this for a moment, Devin. If I'm doing my division in standard algorithm, I wouldn't have the other way, would I? So this is not that's not that kind of check. Emma.
Could you use multiplication and check it?
I could. 6 times 8 is 48. But really what I want to check is this number right here. This 0. If I get a number, let's say I subtract like I did and I get 0. Is 0 less than 6? Yes, which means I did everything correctly because 6, there's no more 6's I can get out of that number. No more groups of 6, right? What if I subtracted and I got 8? Can I get another group of 6 out of that? Sure I could. So that means that this number would be too small and I'd have to start over. So when you check, you're checking to make sure that this number is less than this number. If it is, good to go. If it is not, you need to erase and try again because your number is probably too small. Or you made a subtraction error, in which case, in both cases, you need to check. Alright, so my next step is to bring down. So I come over here to this 2. Remember the 2 we forgot about? Now the 2 gets to come back in. So I'm going to bring the 2 down here. So, I drop the 2 down next to the 0. I want you to think of standard algorithm kind of like a waterfall, okay? It starts at the top and the water flows down. That's what standard algorithm does. We start with the number in the divisor. It's called the dividend, remember? We start with the dividend, but it kind of flows downward as we keep dividing. So now we're down here. So we come back up to the 6, but look where it's going to divide now. We go back to the beginning and we divide. Can 6 divide into 2? Why not? Alla.
Because 6 is bigger than 2.
And if I have 2 erasers, can I give them out to 6 people?
No.
Not enough. So so if 6 goes into 2, 6 does not go into 2. How do I say no in math? Abigail.
Put a remainder.
No, not yet. How do I say no? It doesn't work in math. No. A zero. So 6 divides into 2? No, it does not. Right? This is a common error that some kids will make. They'll get here, they'll say 6 doesn't go into 2, so it's just 8 remainder 2. Well, that is not correct because 8 times 6 is 48, not 480. So I need that 0, don't I? Okay. Now, we erase that. So now, since 0 is here, I go over to my next step. What's multiplication? 0 times 6 is? 0. Put it right underneath that 2. Go to the next step, subtract. 2 minus 0 is? 2. Check. Is 2 less than 6?
Yes.
So we're good to go. My last one is bring down, but is there anything left to bring down?
No.
So that means you're done. Unfortunately, though, we didn't get to a 0 here, so this is again my remainder. So I get 80 remainder 2. Is that what we got for our last problem?
Yes.
When we did partial quotient, we got the same answer, didn't we? So you can see that both ways will get you to the answer. Which one do you think is easier? Partial quotient. Partial quotient is easier because you get to use multiplication, and you're most familiar with multiplication. But standard algorithm is faster because if you know your multiplication facts, it's real quick to just do the division and get there. For example, when I did this part right here, did I have to subtract 0? No. You'll get to a point, I would like you to do it now just so that you're getting the process down, but you'll get to a point where you'll say, oh, 6 times 0 is 0, oh, then I just have remainder 2. Because at that point you realize that the step doesn't change anything if I put a 0 and subtract. Okay? Any questions on that? We're going to practice and practice and practice this until you get this stage down of division using this standard algorithm so that we can get this one in your brains. And then you'll have 2 ways to do division in the future, which you'll need for 5th grade, right? 5th graders do a lot of division. So you'll be all ready to go when it comes time to divide in 5th grade. Okey-doke? All right, we're going to practice. Are you ready?
Yes.
Can't hear you.
Yes.
Can't hear you.
Yes.
That sounds exciting. All right, we're going to get started. Thank you so much for being great listeners.